Hello everyone! In this opportunity, we are going to continue with the APPI 2 course, with the second topic on flight mechanics. If you didn't watch the first part of flight mechanics from the APPI 1 course, here I leave you the video. In this opportunity, we are going to talk about the following topics: angles of attack, pitch theory, the causes of a stall and negative spin, symmetric collapses, and asymmetric collapses. Let's start with the angles of an airfoil. Here we have an aerodynamic profile. We know that our paraglider is like the wing of an airplane. It flies because it has an aerodynamic profile. In this profile, this is the front part, the leading edge, and this here is the back part, the trailing edge. There are three important planes to understand the angles, because an angle is one plane against another plane. The first one is the chord. The aerodynamic chord is this line, this plane that connects the leading edge with the trailing edge. The second is the horizontal line. The horizon will always be a completely horizontal line. And the third is our flight path. It is the trajectory along which we are flying, the path along which the paraglider is flying. The angles formed between these planes are the most important angles of the airfoil, and there are three. The first one, formed between the aerodynamic chord and the horizontal line, the horizon, is called the angle of incidence. Then the angle formed between the chord and the flight path is called the angle of attack. And finally, the angle formed between the horizon and the flight path is called the glide angle. So to summarize, we have our aerodynamic profile. We have three planes or axes. The first is the flight path, then we have the chord, and we have the horizon. The angle formed between the chord and the horizon is called the angle of incidence. The angle formed between the chord and the flight path is the angle of attack. And the angle formed between the horizon and the flight path is the glide angle. Now, how is each of these modified? The angle of incidence will not be modified by braking. The only way to modify it is by accelerating the paraglider. In a single-seat paraglider, by using the speed bar, pressing the accelerator, and in a tandem paraglider, by using the trimmers. It is not modified by using the brakes. On the other hand, the angle of attack, formed between the chord and the flight path, is modified both when we use the brakes and when we accelerate. In other words, the angle of attack is the angle that we are almost always modifying while flying. If we brake the paraglider or use the accelerator, we are modifying the angle of attack. And finally, the glide angle is modified when we use the brakes, also when we accelerate, and additionally when the intensity or strength of the wind decreases or increases. So the glide angle is the one that fluctuates the most in real flight, because it depends on how much we brake, how much we accelerate, and how much headwind or tailwind we have. In previous topics, we have already seen the three axes of rotation of a paraglider. On the vertical axis, we have yaw. On the longitudinal axis, we have roll. And on the horizontal axis, we have pitch, which is the topic we are going to develop next. Of the three movements, pitch is the one we must be most careful with, because as a result of extreme pitch movements, we have the so-called collapses. So in order to prevent a collapse, we must know how to control pitch. And at the beginning, this is not so simple. To begin with, if we have small pitch movements during flight, sometimes we are flying a paraglider that is a little big for our weight, or the wind is a bit active, a bit turbulent, and we have small pitch oscillations. It is not necessary. It is not 100% mandatory to control them. We can fly with a bit of pitch. It will be a bit inefficient, but we will not be at risk of a collapse. However, if we have a pronounced pitch movement, a strong or violent pitch, then it is necessary to control it. The theory is the following. To control it, we must break the wing in the necessary proportion until we feel pressure again. Because when the paraglider suddenly surges forward, we will lose pressure in the brakes, we will lose weight in the brakes. So we have to brake until we restore and feel the pressure again, but at the right moment. Once we have braked, we must raise our hands. We must not continue braking, because even if we brake at the correct moment, the paraglider in front of our head, moving forward, we brake, the paraglider returns to its original position, and if we continue braking, we will cause the paraglider to fall back again and subsequently pitch again. So we must brake at the right moment and then raise our hands. And what is the right moment? When the paraglider has passed above our heads, is in front of our heads, and is moving forward. Because if the paraglider is in front of our heads but is moving backward, if we brake at that moment, what we are going to do is worsen the pitch. We are going to make it more extreme, and the pitch will continue. So we have to brake the wing. If it is a light pitch, we brake a little. If it is a violent and fast pitch, we brake a lot. We could brake almost 100%. If the paraglider is very far forward, we have to brake whatever is necessary. And remember, if the paraglider is very far forward, it is almost impossible for it to stall. It will stall if we brake 100%. The paraglider reaches its normal position. We keep braking. The paraglider falls back. We keep braking. And then it stalls. But if the paraglider is surging forward violently, we brake almost 100% and then raise our hands. The paraglider will simply return to its original position, and it will not stall. So we should not be afraid to brake whatever is necessary when we have an extreme pitch movement. In summary, when pitch is violent and could cause our paraglider to collapse, we will feel the paraglider surge forward, and we will feel our brakes lose pressure. So we will have to brake the wing as much as necessary. 20, 30, 40, 60, 80, almost 100% of brake, at the right moment. When is that right moment? When the paraglider has passed above our head and is moving forward. If the paraglider is moving backward or is behind our heads, we must not brake, because if we brake at that moment, we will increase the pitch. We will make our wing fall back and then pitch even more violently. When do these extreme pitch movements happen? They can happen when we enter a rotor or turbulence. Rotors are one of the main causes of collapses, and you can almost always see the paraglider pitch immediately. A normal pitch movement happens when the paraglider first falls back and then surges forward. But in a rotor, the paraglider is flying perfectly, and suddenly, if the rotor is strong, we will see the paraglider pitch directly without having fallen back first. When the paraglider pitches directly and collapses, it is normally due to a rotor. Another cause of pitch is simply flying in strong conditions, in turbulent thermal conditions. When we enter and exit a thermal abruptly, we will see how the paraglider first falls back a little and then surges forward, and if it is not controlled, it collapses. This falling back can be because the pilot entered a strong thermal, the paraglider fell back, and then the pilot did not control the pitch, either entering the thermal or immediately exiting it, and the paraglider surges forward. So in strong thermals, we will see that before pitching forward, the paraglider falls back a little. Another cause of dangerous pitch movements is when we exit a maneuver incorrectly, usually spirals. There are novice pilots, even student pilots, who start practicing their first 360-degree turns or spirals and exit very abruptly. They exit the spiral, the paraglider falls back, and then pitches forward violently. In fact, to this day, I have witnessed accidents of student pilots due to this type of situation. Students want to learn spirals on their own. They exit badly. The paraglider pitches violently. They collapse, and then enter a series of subsequent incidents. It can also happen from exiting a wingover or a large pendulum maneuver incorrectly. We exit badly from a big pendulum. The paraglider falls back, pitches, and collapses. Also, although less likely, it can happen when exiting a full stall incorrectly. In a full stall, the paraglider stalls, and then we must enter a configuration called backfly, which is like a half stall, so that the paraglider does not have so much energy, and then release it. But if from the full stall we raise our hands quickly, the paraglider will pitch and collapse. It can even happen that the pitch after a full stall is so pronounced, so large, that we end up with the paraglider below us. It has even happened that the pilot falls into the paraglider. But this is already a case of extremely violent pitch, and usually results from exiting a full stall incorrectly.